Okay, here is example 9C from page 259. We've got sine of x minus pi over 6 equals negative 1/2. Restricted domain still from 0 to 3 pi. So we're still thinking about this idea of sine theta equals negative 1/2. Where on the unit circle does that happen? And it is here and here at 7 pi over 6 and 11 pi over 6. So that's the first thought process we need to go through. All right, so, but we don't just have theta anymore. We have x minus pi over 6. So instead of saying theta equals these two things, we have to say x minus pi over 6 is equal to these two places. So we're going to write them like this with that special violin bracket. Now, what is this period of a sine function? It's 2 pi. So this is going to happen every 2 pi in both directions. K is just our integer. Could be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. So it just tells us how many rotations we're going around the unit circle. So plus 2k pi for both of those. Now, next step, just normal algebra. How do we get x by itself when it has subtract pi over 6 with it? We need to add pi over 6 to both sides of the equation. So we will do that. I'll write that step out here. Plus pi over 6 to both of these. And connect them with that violin bracket so we can see we're working with two different sets of solutions. All right, moving this up a little bit. We have more work to do. We're going to now actually do that. We're going to add these things, so simplify each of these. Pi over 6 can be put together with 7 pi over 6. So our next step is 8 pi over 6 plus 2k pi and 12 pi over 6 plus 2k pi. All right, these will both be easier to work with if we simplify those fractions. 8 over 6 is the same as 4 over 3. So 4 pi over 3 plus 2k pi. Notice this time around, nothing happened to the 2k pi because we're not dividing by anything. We're just adding pi over 6 this time. We're not dividing by 2 like in example 9b. 12 pi over 6 is 2 pi. All right, so here's our two sets of solutions. We need to be thinking about our restricted domain between 0 and 3 pi. So if we put these as equivalent fractions over 3, this would be 0 pi over 3, or 0, and this would be 9 pi over 3 is equal to 3 pi. All right, move up again, and the board here. So we're looking for our first solution, 4 pi over 3, and we're going to be adding 2 pi or subtracting 2 pi over and over again. Well, 2 pi is 6 pi over 3, so minus 6 pi over 3, and also adding 6 pi over 3 over and over again. This would be negative 2 pi over 3, which is too small for our restricted domain. 10 pi over 3 is too large for our restricted domain. Okay, so we just have 4 pi over 3 from that answer. However, with 2 pi, once we subtract 2 pi, we get 0. That is still within the restricted domain, so that's a good answer. If we add 2 pi, we're going to have 4 pi, which is too big, so we don't have that. So our final answer is 3 solutions, 0, 4 pi over 3, and 2 pi. So 3 solutions within that restricted domain.